In this video, we are going to go through 2017 paper 2 question 10. We will focus our discussion on part B, okay, in which they tell you there's a small mass hanging freely from a string suspended inside a car. Okay, and then part 1, okay, wants you to draw and label the forces acting on the mass, okay, and pay attention that this is for the mass at a time t equals to 30 seconds. So what is the significance of this time? Okay, you need to link it back to question part A. All right, okay, so remember that part B is an extension from part A. Okay, and then if you look at the entire question, this question stem, right, that gives you the context of the entire question. This is in front of part A and part B, which means that the entire graph, okay, 10.1, figure 10.1 applies for the rest of the question parts, A, B, C, or whatsoever. All right, okay, so now for part B, you need to look back at time t equals to 30 seconds, what is happening to the car's movement. Okay, and we see that constant velocity, which means that the car is experiencing zero acceleration, which means that zero net force experienced by the car. Right, so from this one, okay, let's do the B part 1. So since net force is 0, okay, and we know that downwards vertically there must always be the weight acting. Along the string, upward is tension. Okay, so draw in these two forces and label the name of the forces in full, right, spell it out. Okay, and one more detail that you need to be careful of is that since the net force, right, okay, is 0, the arrows of the two forces, okay, must look visually similar in length. All right, okay, so now for part 2. Part 2, the task is for you to explain using Newton's laws of motion why the string is vertical even though the car is moving. All right, okay, so meaning they want you to give an explanation of even if the car is moving, right, okay, how can the string be still hanging vertical. Okay, and part 1, where they let you draw the free body diagram, right, is actually a guidance, right, guiding you to answer towards part 2. Okay, so from part 1, we have already figured out that net force acting on the ball must be 0. Alright, okay, and if net force is 0, okay, then immediately you must also make the deduction that the Newton's law, right, okay, that should be applied in such a situation must be Newton's first law. Right, okay, and in part 2, you need to work Newton's first law into part of your argument. All right, okay, so now let's organize our statements. Okay, so since the question has this part that says even though the car is moving, right, okay, then how come the string is vertical? So to address the even though the car is moving, right, refer back to the graph, the figure of the graph, right, okay, to make the statement that at time t is equals to 30 seconds, the car is moving, right, okay, but it is with a constant velocity. And the significance of constant velocity is that acceleration of the car must hence be 0. Right, okay, so by Newton's first law, right, okay, so here we start to invoke and weave into our argument. So by Newton's first law, 0 acceleration must mean that the mass is experiencing 0 resultant force. Right, okay, so that is our first statement. Okay, and the next part, right, okay, is to continue our reasoning, okay, such that when the how can it be that, right, okay, from the free body diagram we can see that two forces are acting on the mass, okay, but how can it be that when there are forces acting on the mass, okay, the net force can come to be a 0 value. Okay, so here we see that, well, weight is always acting vertically downwards. So since the weight acts vertically downwards, and in order to get a resultant force that is 0, okay, it must mean that the other force, which is tension, okay, must then be acting vertically upwards, so that it is possible for these two forces acting on the mass to exactly counterbalance each other, okay, and the resultant force comes to be 0 in value. Right, okay, so hence the string must then be straight. Okay, so here this is a classic case in which you can see that for this kind of explain question, right, okay, we have discussed about the CR framework. So this is a very nice example of where the CR framework can help you to answer the question in a very complete manner, right? Okay, the part where we pick out that the car is moving at constant acceleration and so on at the given time, right? So this we had to refer back to the given graph. So this one is like picking out the evidence, all right, okay, the data that is given inside the question, all right, okay, that picking out this particular timing, picking out this particular part of the graph, right, allows you to make this further deduction, right? Okay, so this therefore is a important part inside this explanation question, all right? Okay, so that is the evidence part. Okay, and the next part, okay, where we reason, right, okay, argue towards why the two forces of the weight and the tension can come to exactly counteract each other, okay, such that the net force can become zero, right? Okay, so this part, right, okay, and actually also the Newton's first law part, right, okay, that leads from zero acceleration, right, okay, allows you to deduce that the resultant force must therefore be zero, and resultant force being zero, okay, leads to the further reasoning that when one force is vertically downwards, the other force must hence be vertically upwards. So this constitutes the reasoning part of your answer, right? Okay, and the claim, right? CR, the C stands for claim. The claim is actually given to you, hence the string must be straight. This is the claim, and this is the conclusion that your evidence picked out, your reasoning, your arguments, right, okay, must link, connect together and argue towards this claim. All right, okay, so we will look now into the part 3. All right, okay, so on the diagram, sketch the position of the mass and the string at time t equals to 5 seconds. Okay, so again, what is the significance of this time? Right, okay, so you need to look at the graph again. So at time t equals to 5 seconds, you see that this part of the graph, there's a slope on the velocity time graph. It means that, okay, there is acceleration experienced by the car, right? And since the slope is a straight line, right, okay, so use a ruler to test, okay, to see that it is a straight line. Okay, so it would mean that the car is experiencing uniform acceleration. So uniform acceleration, right, okay, can only be experienced when the mass and the car, right, okay, is experiencing constant net force. Okay, so from here, right, okay, this is going to help you to answer your part 4, right, okay, but the question in part 3, right, okay, ask you to draw, right, okay, the sketch position of the mass first. Okay, so this is actually a guidance question part, right? Okay, so from the everyday experience, right, okay, you know, when you are in the car and then when the car accelerates forward, right, okay, so you will observe, or if you're on the MRT and then the MRT is accelerating forwards, when it's not broken down, the MRT can move, right, okay, then you will observe that the handles, right, okay, the grip handles, right, okay, will swing backwards. Okay, so from there, okay, the everyday observation, all right, okay, of how things physical motion, right, okay, and things behave, right, okay, around us will help you to then draw the diagram, okay, of the mass, right, okay, to fall towards the left side if the car is accelerating towards the right side, okay, in the forward direction. Okay, so from here, the next part of the question is, okay, again using Newton's law to explain your answer to B part 3. All right, okay, so what does it mean by your answer to B part 3? Okay, it means why do you, right, okay, why do you think that, okay, the mass would fall towards, will be shifted, right, okay, towards the left side, okay, and meaning, okay, why the string, all right, okay, is inclined towards this way. So here, all right, okay, I think this part 4 is needs you to think carefully a little bit, All right, okay, and actually it is a little bit similar to part 2. Part 2 is kind of like preparing you for this part 4. All right, okay, because in part 2, remember that we discussed about, okay, the free body diagram. One downward force, one outward force, therefore the net force can become 0. All right, okay, so now in the part 4, if you think about, okay, the perspective of the mass, right, okay, just forget about the car, okay, focus on the mass. Right, if the car is accelerating forwards, it must mean that the mass which is also attached to the car, okay, must be also, right, okay, accelerating forward, must also be experiencing a forward acceleration, right, okay, because it is moving along with the car. Right, okay, so in order for this to be true, right, okay, such that the mass can be experiencing a rightwards acceleration, right, okay, so let's take a look at the way that we have drawn the string. Right, okay, so the string is drawn and it is inclined towards the right hand side. So what does it mean for the two forces acting on the car when the string is inclined in a direction like this? All right, okay, so now let's draw in the two forces again. Right, weight always acts downwards. Okay, so vertically downwards, no change. But when the string is inclined in a direction like this, the tension forces always act along your rope, cable, or string. Okay, so now your tension is inclined in a direction that looks like that. Okay, so now if you apply your net force, summing up of forces, okay, doing vector sum of forces, if you do that, apply that scale, right, okay, then using the triangle method, right, okay, if the weight acts downwards and the tension is inclined in a direction, okay, that is slanted towards the right this way, right, okay, but the thing is we do not know how, the magnitudes of these two forces, right, okay, and therefore, right, okay, if you look at, okay, the way that the string, the tension is slanted, okay, you will see that it is possible, therefore, for the resultant force of these two, right, okay, this vector plus this vector, right, in the triangle method, to produce a resultant force, right, okay, that is along this direction, right. So there can be a certain value of the tension that results in a resultant force that is acting horizontally towards the right side. Okay, so so this is the reason why the string must therefore be inclined towards the right side this way. Okay, you can also do this by proving, okay, what if the string is inclined in the other direction? Okay, so weight again can only act vertically downwards. So if the string is acting in the other direction, okay, then the tension would be acting towards the left, okay, in such a direction. Then your resultant force, okay, would be towards the left this way. Okay, and for a car that is moving rightwards, accelerating rightwards, okay, it's not sound, right? Okay, for the mass, right, okay, connected to the car to be accelerating towards the left hand side. All right, okay, so so it must move along with the car. All right, okay, so therefore, okay, the inclination of the string must be towards the inclined towards the right hand side this way, okay, in order for the mass to be able to move along with the car, right, meaning experiencing the same direction of acceleration similar as that of the car. Okay, so now let's organize these thoughts into two concise statements. Okay, so again, we will do the evidence part, which is, okay, pick out what the graph is saying to us. So at time t equals 5 seconds, the car and therefore the mass is accelerating towards the right. So there must be a resultant force acting on the mass, right, okay, towards the right side. Teacher forgot to write Newton's second law. All right, okay, so resultant force acting on the mass towards the right side. right? Okay, so since weight of the mass acts in the vertical direction, the tension of the string must therefore be in a direction inclined towards the right. Right, okay, so that the resultant force can be towards the right to provide the rightwards acceleration. Okay, so here I just realized that I have forgot to add in the Newton's second law. Right, okay, so since the car has acceleration, is experiencing acceleration, so the law to apply obviously is Newton's second law. Right, okay, so we will weave in, okay, Newton's second law somewhere over here. Alright, okay, so the mass is accelerating, right? Okay, so by Newton's second law of motion. Alright, okay, so here I address the requirement of the question, okay, to show use of the Newton's laws. Okay, and here it is Newton's second law. Alright, okay, that should be applied. Right, okay, so at time t equals to 5, the car, and so the mass is accelerating towards right. So by Newton's second law of motion, there must be a resultant force, right, acting on the mass towards the right. Okay, because Newton's second law states that the direction of the acceleration follows that of the net force, right? And whenever there is a net force, there will be an acceleration and vice versa. Alright, okay, so this is a good place to weave in our Newton's second law. Alright, okay, so yeah, this is it, okay, for this question.